Okay, we're going to move into our final lesson of our conic sections unit, Unit 9, and that is talking about hyperbolas. So our essential question remains the same as previous days. We want to know how we graph or construct the equation of a conic section. And for today, we're looking to graph a hyperbola based on its characteristics, and then also create the equation of a hyperbola based on given information. Same setup that we had previously with parabolas and ellipses. We're going to talk about the definitions first, the equations. We're going to go into a few examples, and then we're going to end on looking at information and then creating an equation. So, definition, which just like the previous 2 days, is wonderful. It's not particularly helpful for you before you do problems, but it might be something you come back on after you finish and then reflect on it a little bit. And moving into the formulas, we can see the same general setup that we had before. Now, talking about the difference between yesterday and today, things that I want to point out. If we notice, and I'm going to erase this eventually, but for right now, notice I have subtraction in both of these. Yesterday was addition, and so if it's ever adding x squared and y squared, that's going to be an ellipse. If we're subtracting them, that's going to be a hyperbola. Also, with hyperbolas, notice the a squared is always beneath the x squared. Or sorry, the a squared is always the first denominator. And what I mean by that is a squared is in both locations. What flips is the x squared and the y squared. So the orientation of your hyperbola, whether it's left, right facing, or up and down facing, and we'll talk about that, it's going to be what comes first, x or y. So that's the main difference between ellipses and hyperbolas. Obviously, the graphs look different, but a lot of times you guys get tripped up because you're not sure which formula is related to which situation. So here's how we get into it. Our first one, the far left one, is left and right facing. And I know that because my x squared comes first. So that's going to be worth writing down. X squared comes first. And so again, oriented left and right because x squared, which is affected by left and right movement, comes first. In this situation, my vertices are plus or minus a comma 0, just like they kind of have been. We're also given foci, which are plus or minus c comma 0. To create the structure of our graph, we are also looking at asymptotes now. It is going to be an oblique or a slant asymptote located in the equation y equals plus or minus b over a times x. And your final graph will look something like this. It's left and right facing. So we get a situation that looks like this. Okay, so my vertices are plus or minus a. So there's my a comma 0. This should be my v1. Negative a comma 0, which is v2. We are also given two foci. There's f1, located at the point c comma 0. And we also have f2, negative c comma 0. Now, to get the asymptote structure, we're going to go up b and right a units. And so that gives us a general borderline here. And what that does is it gives you the structure on the outside of your graph. So that's going to be what gives me, what tells me how wide apart my hyperbola is. When we're given a different situation, in other words, when y comes first instead of x, this is going to be up and down facing. Again, y squared comes first. everything is flipped. Your orientation is flipped. So instead of having vertices at negative plus or minus a comma 0, now your vertices are located at 0 comma plus or minus a. Your foci, same thing, they flip. We're looking at 0 plus or minus c now. Your asymptotes flip-flops as well. And we're now looking at y equals plus or minus a over b times x. And when we go to sketch the graph of what this would look like, the vertices are going to be there and there. Here's my v1, which is 0 comma a. That's our v2, which is 0 comma negative a. We have our foci, 0 comma c. Kind of looks like a c. And your f2, which is 0 comma negative c. With the asymptotes, we are given up a units and then left or right b units. So I'm going to say that's b. So we count up and over. Same thing, we go up and left as well to go to negative b. And that tells us how wide our graph is. In purple. And we get that general shape. So things that I want to point out, again, a squared is the first term, no matter what now. Hyperbolas are going to have vertices on the first letter's axis. So what that means is if x squared comes first, it's going to be oriented left and right. If y squared comes first, it's located or it's oriented up and down. And the foci are always on the axis of the vertices, located c units from the center. And here our center was 0, 0. And just like last time, we always start with the center at 0, 0. And we talk about, should be ellipses here, can have hyperbolas not centered at the origin, which does occur. How we graph is located below. Plot the vertices, we dash in the central box, and that's where we're going to use the asymptotes. Typically, I don't use like a dashed central box. I just use the asymptote structure, and then extending the diagonals to show the asymptotes, yay, and then drawing the hyperbola through the vertices, making it approach the asymptotes. And that's that step that we did last. That's kind of like my purple, the purple graph approaches the dotted line. But you'll see how we do this as we go through. So starting off on the first example, which that's always just kind of dive in a little bit and then struggle through it. We're always going to look for the center first. And so in this case, our center is 0, 0. I know that's my center because if you notice there's nothing attached to the x or the y, that makes it either added or subtracted. So my center is going to be 0, 0. So I'm going to draw my center there. We are also given vertices. And my vertices are going to be plus or minus a. So in this case, a squared equals 9. So that means a equals plus or minus 3, which means my two vertices are going to be focused on the point 1, 2, 3. Here's my first vertex, 0, 3, and my second vertex is 0, negative 3. I know that is oriented up and down because my y squared comes first. I'm going to say y squared comes first. So it is oriented up, down. That's how I knew to go up and down from the center rather than left and right. Looking at my foci now. My foci are plus or minus c. And so we're given an equation that says a squared equals c squared minus b squared. Well, we know a squared is 9. We know b squared is 16. So that means c squared is 25, or c equals plus or minus 5, which means I'm going up 5. That's my first focus. So 0, 5, and down 5. Okay, so we end up with those two. Last but not least, we are looking at our asymptotes. And if we have a hyperbola that is up and down oriented, remember we're looking at our equation here which says plus or minus a over b. So y equals plus or minus a over b times x. Well, in this case, a is going to be the square root of 9, or 3. B is going to be the square root of 16, which is 4. So our equation is y equals plus or minus 3 over 4x, which means we go up 3 and write 1, 2, 3, 4. And we also go down 3, right 4. Now, if you're referencing the book, what your book does is it makes a box out of these. To further get the structure of your shape. For me, that step is a little bit redundant because your last step for me, I would assume would be, well, okay, I'm starting at my vertex and I'm getting very close to that asymptote, which is in blue. I'm getting very, very close to that asymptote in blue. Same thing on this side. I'm getting close. I'm getting close. So I typically don't draw that box, but if you're looking at the directions and if you're looking at the examples in the book, that's what it refers to when it says dashes in central box. So if you want to do that step, that's fine. Otherwise, I'm okay with you leaving it out. Either one's okay with me. Okay, so that's when it was centered at 0, 0. We're going to stay centered at 0, 0 for a little bit because the asymptotes are a little bit hard to keep track of if they're not. Just like yesterday, we have to set it equal to 1. So our first step is going to be dividing everything by 225. And when we do that, we end up with the equation x squared over 25 minus y squared over 9 equals 1. And so now we have the format that we need. Our center here is going to be 0, 0 again. Our vertex, or our vertices, are plus or minus square root of a. So in this case, our a is plus or minus radical 25. And so plus or minus 5 times 0 is going to be our vertices. By the way, this is oriented left, right, since x squared is first. And we can also find the foci. We have a squared equals c squared minus b squared. So in this case, it is 25 equals c squared minus 9, or 34 equals c squared, or c equals plus or minus radical 34, which does not simplify, but that's about, I believe, 5.9-ish. About 5.8, give or take. And that's not going to be part of how you write it, but it does help you graph accurately, knowing that it's about 5.8. And then we also need to look at the asymptotes. And so our asymptotes, because it is left and right oriented, it's going to be plus or minus b over a times x. In this case, our b is 3, our a is 5. And so our equation is plus or minus 3/5 x. And so now we can graph all that. We know the center is 0, 0. We know the vertices are plus or minus 5 and negative 5. Those are v1, 5 times 0. By the way, if you flip v1 and v2, or if you have the exact opposite of me, that's perfectly fine. It's the same deal. My foci, how we would write that, it's not quite 6. It's about 5.8 right there, 5.8 right there. As we're looking at this, our f1, how we would communicate that is root 34 comma 0. The square root of 34 does not simplify, so we would have no need to do that. And so f2 would be negative root 34 comma 0. Looking at the asymptotes, we would start at our center and go up 1, 2, 3, right 5. And so that's our first asymptote. The second one is up 3, left 5, or down 3, right 5. Again, if you want to make that box fill in, you can do that. For me, that junks it up a little bit too much, so that's what you'd use to graph. For me, I'm going to get rid of it. And I'm looking at this going, okay, that's my vertex. So my graph looks like this. And we get our general graph.
Can I get an escort to Coach Hood?
Especially when we start getting equations and situations.
Greg, I'll be right there, man.
Thanks, Bob. Especially when you start getting situations where our graphs become more complicated, it might be to your benefit to do something like this. Your center is 0, 0. Your vertex is 5, 0, and negative 5, 0. And your foci are radical 34, 0, and negative root 34, 0. If that's helpful. If you are better than I am at structuring your graph accurately, then that might not be necessary. But if it's a little bit of a cluster looking at your graph and you can't tell which is which, it might be to your benefit just to list it out. Okay, so let's go to our last example that we're going to have today. That's of this type. And when we start moving the center around, it gets a little bit more complicated. Keep in mind that this is technically over 1. And things that I can tell from looking at this, first and foremost, it is oriented up and down because y squared comes first. Other stuff, my center is no longer 0, 0. Our center in this case is negative 3, comma, positive 1. And notice that this is going to be my h, and this is going to be the k. K always goes with y's, h always goes with x. So we know the center is there. Now jumping into the vertices, a squared would be 25, so that means a equals plus or minus 5. And so we're going to go through this piece by piece, starting with the center and graphing the other points around it. So I'm going to graph that center first. So 0, 0. Oh, sorry, that's not my center. Just kidding. In this case, my center is negative 3, 1. With my vertices, I know that it's oriented up and down. So what my vertices mean is I start at my center and count up 1, 2, 3, 4, 5 from the center, and down 1, 2, 3, 4, 5 from that center. And so our vertices, V1 is going to be the point negative 3, 6, and V2 is the point negative 3, negative 4. So it's not just 0, your value for A. You have to actually count up, down, left, or right, and right from your center, depending on if it's oriented up, down, or if it's oriented left and right. Next, jumping into the foci, we have that a squared equals c squared minus b squared equation. And in this case, we have 25 equals c squared minus 1. So 26 equals c squared, which implies that c equals plus or minus radical 26, which is roughly 5.1 maybe. Second square root of 26, 5.1. Okay, so what that means is I start at the center and I count up 5 and down 5. It's going to be about there and there. But just like last time, remember we are not just doing 0, that value. We are starting at the point negative 3, 1, and we count up square root of 26. So how we'd write that is we start at the center point and go up radical 26. That's why it's a plus. And so for not V2, but F2, it becomes negative 3, 1 minus, because I'm counting down from it, radical 26. Okay. Now jumping into the asymptote. That is y equals plus or minus a over b times x. And here's where we have to be careful. This looks like it's plus or minus 5 over 1 x, and it kind of is, but keep in mind that's 5 over 1 from the center. So counting from that black point, up 5, right 1, and we get this dotted line. And it's also up 5, left 1. That's about as accurate as I can make it. But I do want to point out that that's not your equation. And so we have to do a little bit of legwork to find the actual equation of that asymptote. So when I said legwork, here's what this means. My slope is plus or minus 5. So we have two scenarios, and we're going to deal with those separately. So let's do slope 1. So case scenario 1, m equals 5. Scenario 2 is going to be m equals negative 5. If m equals 5, we know that it has to go through that center point of negative 3 comma 1. So we need to write this in slope-intercept form. And so y minus 1 equals 5 times x minus that negative 3, which is really a plus. Solving for y minus 1 equals 5x plus 15. Add the 1 over. Our first asymptote has the equation y equals 5x plus 16. The second equation, do the same thing. Y minus 1 equals negative 5 times x plus 3. That's changing the sign in the middle. And so this becomes y minus 1 equals negative 5x minus 15. Add the 1 over. Y equals negative 5x minus 14. So our asymptotes have that equation. So a little note here. When the center is not located at 0, 0, the asymptotes are found by using point slope form. So that's something to keep in mind as you go through different problems. If your center of your hyperbola is not 0, 0, your asymptotes can only be found by using this structure. And then last but not least, we have to draw our graph, which looks something like this. And as the same as yesterday, your focus is always located inside of your hyperbola. Okay, so moving on to the last couple, and just so we can get this out of the way, I'm going to say that this is plus 5 extra credit quiz points, if you want to do this one on your own and check it with me. But we're going to go through 4 and 5 together. And just like yesterday, my suggestion is always usually pretty much the same, and that is, you know, it's a lot of information initially, so graph it. So we're going to put this all together. So my center is negative 1, 1, 2, 3, 4. The vertex is negative 1, negative 3, 1, 2, 3. So my vertex is there, and my other vertex is negative 1, 5, 6, 7, 8, 9, 10, 11. Okay, that's negative 1, 11. This is negative 1, negative 3. We also have two foci, and my foci are negative 1, negative 5. And negative 1, 13. Okay, so we have those labeled. And now we start talking about what this looks like. Because everything is located in a vertical line, we have a vertical orientation, which looks like this. Y minus k squared over a squared minus x minus h squared over b squared equals 1. And it's up to us to kind of take that information and work backwards. So we know the center is negative 1, 4. So right away that tells me what h and k are. So we can write our equation as y minus, actually y plus 1 squared and x minus 4 squared equals 1. And now it's up to us to find a and b. Well, a is the distance from the center to the vertex. So that distance is a. So in this case, a looks like it's going to be 7. So the distance between 4 and 11 is 7, as is 4 to negative 3. So if a is 7, then a squared is 49. Now, we don't know b squared right away, but we do know the distance between the center and your focus equals c. And the distance from 4 to negative 5, or 4 to 13, is 9. And so if we use the equation a squared equals c squared minus b squared, we know that a squared is 49, we know that c squared is 9 squared, which is 81, and we know that b squared is what we're going to be solving for. Subtract the 81, we have negative 32 equals negative b squared. So 32 equals b squared. And now we can take that mess and plug it in. And we have our equation. So it's a matter of knowing your rules and being able to work backwards. And as I'm looking at this, actually I have a mistake. My h and my k need to be flip-flopped. My h goes with my x, and my k goes with my y. So in this case, it should be y minus 4 squared and x plus 1 squared. So if you caught that and yelled at me in the middle of class, good for you. If you thought you caught me and kept listening, so be it, but make sure that you're making that correction before we continue. My mistake for throwing you off a little bit. Okay, last but not least, we have something that we can graph. My vertices are 0, 1, 2, 3, 4, 5, 6, and 0, 1, 2, 3, 4, 5, negative 6. So my V1 and my V2. Okay. By the way, looking at this, my center has to be 0, 0, because my center is going to be halfway between my vertices. And the asymptote is 1 over 3, which, if everything is located vertically, remember that it's y equals plus or minus a over b times x. That's your equation. So what we're able to do, I know that my center is 0, 0. I know that it's oriented vertically, so this becomes y minus k squared over a squared plus x minus h squared over b squared equals 1. And by plus in between, I mean a minus, because it is a hyperbola. If it would have been a plus, it would have been an ellipse. If my center is 0, 0, that is our h and k. So that's really 0 and 0. Also, it looks as if we have a over b here, well then 1 equals a, and 3 equals b. So we should be able to go y minus 0, or just y squared, over a squared, which would be 1 squared, which is 1, minus x squared over b squared, which is 3 squared, which is 9, equals 1. And that sounds good, but it's very wrong. And here's why. While this is true, this is reduced. So you have to be a little bit careful here. I know this is going to be reduced because if you take a look at me doing this, if I go up 1, right 3, we end up with this scenario. And clearly that's not going to create the asymptote that I need. So what we have to do here is set up something like this. The distance between the center and the vertex, that's always your a. And so here a is 6. And so what we're able to do, if I know that my ratio, the proportion, is plus or minus a over b, and I know that a equals 6, what we can do is say the ratio 1 over 3 has to be the same as the ratio of 6 over something. So it's a matter of cross-multiplying and finding that. In this case, b is 18. 3 times 6 is 18, divided by 1 is 18. And so when we're plugging this in, This actually becomes 18 squared, or 324. And this actually becomes a squared, or 36. And so our equation is here. So be a little bit wary when you have just the asymptotes given to you. It gets a little bit more complicated than sometimes you initially think. Give yourself a shot. Give the homework problems a shot. It's going to be something that you struggle with, and that's okay. If you get done with the homework, then take a look at this extra credit question. I'd be happy to answer any and all questions that you have tomorrow. Best of luck. Sorry about my couple mistakes on this page. Just a reminder, it is a y minus 4 and an x plus 1 on question number 4. And on question number 5, it should have been subtraction. I initially said addition when I did that. So my mistake. Sorry for throwing you off, and I'll see you tomorrow in class.